Okay, so here's our first question. So, in looking at a lot of the information that's coming out about the COVID virus, we keep hearing, or I keep hearing, I'm not sure if you're following it, but about this thing called herd immunity. And so, herd immunity is a term that's been used as a way to tell when it's kind of safe to return to our what we think of as normal life, when we don't have to use this social distancing and stuff like that. So it's described as a large enough portion of the population that's immune to a disease that would keep the remainder safe from it. So usually we get herd immunity from immunizations. So we, for example, have herd immunity because most of us have to get shots when we're little. Like we have shots for hepatitis, or we have shots for chicken pox now. So we have herd immunity. Okay, so we don't have herd immunity for COVID-19. And so scientists say that for COVID-19, we have to have probably about 85% of the population, some say even up to 90% of the population, have to have been exposed or infected by the disease in order for us to have herd immunity. So problem is, if at a future date, let's say that we have about 7,800,000 people who remain uninfected in South Korea, and the government were to state that there is now herd immunity, how many persons in South Korea by then had been exposed or infected? Okay, so how would we go about solving that problem? Okay, so first we need to define a variable. So we are saying, okay, well, we need to know what the population of Korea is. So we need a variable to represent because we don't know what the population of Korea is based on. We just know that because it says 85% of the population would need to have been exposed. And we know that 7,800,000 remain uninfected in South Korea if we are at herd immunity. And the question we're trying to answer is this: how many persons have been exposed or infected? And we know that's going to be the big number because that's going to represent our 85% of our population. Okay, so we need a variable to represent our South Korea population. Okay, so what we know is that there's two parts to our population, and we're going to kind of do this in a little bit of a picture. Okay, so there's the people who are immune, and there's the people who are, we'll just call them the infected. Okay, so the infected people are going to represent the 85%, so they are our herd immune. And then the other 15%, because that's going to be, remember, our 100% is everybody, is going to be not immune, I'm sorry. And we'll call it, the infected people would be the ones who are quote unquote immune already. So these are our two groups. Okay, so we know that this not immune people, this is our 7,800,000. Okay, and so we know that these people here, this is 85% of our population. So this is our 85% of X. So we know that 85% of our population, okay, is going to be, okay, so we know that these two together represent our total population. So if we were to add these together, we would get 100%. So another way of thinking about it is that 15% of our population, okay, is going to be equal to that 7,800,000 people. Okay, so that not immune group, Okay, so the people who remain uninfected are 15% of our population. So we can actually figure out our population by just looking at these people. And so here's a little tip for dealing with percentages in an equation. And so when you're dealing with percentages, percent sign is an extra symbol in equations, and we don't like to deal with symbols in equations. You shouldn't ever put a dollar sign in an equation. You should never put inches or things like that. So what we do with percents in an equation is you convert the percent to a decimal, and then that way you don't ever use a percent sign. Okay, so let's go back and let's rewrite this. And we're going to get rid of the word of, okay, because of is a word, it's not a symbol. So to make 15% into a decimal, remember what we do is we take the decimal point in the 15, which is right here, and we divide it by 100, which moves it back to the left 2 spots. So that would be 0.15. Remember the word of is multiply, and so we're multiplying by x, so it's going to be equal to 7,800,000. So now we have an equation. So it says 15% of the population is 7,800,000. And now we can go ahead and we can solve it. So to solve it, we're going to divide both sides by 1500ths, or 15%. And so when we divide both sides by 15%, 15% divided by 15% makes 1x, which gives us x by itself. 7,800,000 divided by 15% gives us 52 million. So our solution to this equation is 52 million. Now, the question says, how many persons in South Korea by then had been exposed or infected? So 52 million, remember, our variable is representing the South Korea population. But the question is asking how many people had been exposed or infected by the time we got to herd immunity. So remember, that's 85% of the population. So that means we have to go ahead and figure out what's that 85%. So what we need to do is we need to go one step farther. We need to figure out what is that 85% of that. So what we can do is we already know what 15% of is, 7,800,000. So if we go ahead and we just take our answer and we take away 15%, which was the 7,800,000, we would go ahead and subtract this number from that, and that leaves us 44,200,000, okay, persons, okay, are immune slash exposed. And that would be our statement that actually answers the question. So we've defined our variable. We've written an equation that is going to lead to a valid solution. We've solved the equation algebraically, gotten a valid solution to the equation, and we've written a statement that actually will solve, or which actually answers the question.